Hi, my name is Dusty. I'm an energy coach with Strategic Energy Group, and you are watching a short video on simplifying energy concepts. So our topic for this short video is going to be the penalty associated with a VAV hot water reheat valve that's leaking by. What's going on is the control system has commanded the hot water valve closed, but something is preventing it from completely closing. So consequently, hot water is leaking by, and there is a big penalty associated with that in terms of energy and also in terms of occupant comfort. So let's go in and talk about some of the symptoms first. Now, for a hot water valve that's leaking by on a VAV, you're going to get some obvious symptoms here, and we want to talk about them. The first one being your boiler system will be in operation, and you're going to get some comfort complaints, but you're going to get too hot and too cold together, and that should seem a little odd to you, right? And another one would be your air handler. So let's say you have a air handler that has a discharge air temperature reset, and the reset range on this air handler, the set point is going to be towards the lower end. It would be lower than you would expect. So in this case, I've got a set point of 55 degree on my fan here, and I'm putting 55 degree air out to the occupant space. And think about those symptoms of the too hot and cold complaints. Too hot is going to likely drive down our supplier set point, and that 55 degree now air is going to be overcooling other occupants, and you're going to get the too cold complaints coming in. So let's go out in the field and talk to one of the occupants that is complaining that they are too hot. So now I'm out in the space and just talk to the occupant. He says it's too hot, and take my infrared thermometer, and when I point up at that diffuser, the air coming out of it is about 79 degrees. So that tells me that I got 55 degree air coming out of the fan going to the VAV, and now it's coming out at about 79. So I got a pretty good delta between the two temperatures. Something is definitely going on with the VAV. So let's get back to our workstation to take a look at the building automation systems graphics for this VAV. So here I am looking at that VAV serving the occupant space that's too hot. It's the supply air coming in about 56 degrees, the temperature coming out about 79, and the hot water valve is commanded to 0% open. No call for heat. We can see that the space sensor is at 76.8 with a cooling set point of 75. So no call for heat, but yet we got a 30 degree delta going across this VAV. We need to head out to the field now and take a look at this VAV and get a little closer look. So now with our head above the ceiling up on a ladder, we're looking right at that VAV. Left-hand side, you can see the hot water coil. And when we remove the cover, a little closer look, you can see the DDC controller for that VAV unit. Those water lines going in and out of the hot water coil, we want to trace those back. So as we trace the water lines further away from the VAV, we finally get to the hot water valve and the actuator motor. That black and orange box there, that's the actuator motor. That's going to turn the ball valve. So this is electrically powered. You can see the cable coming in from the right. And on top of it, if we're in luck, it has a position indicator. So it's currently in the inline position with the water line. So that is, that's open. Remember, there's no call for heating on this valve. We want to see this position indicator perpendicular to the water line. So that's the issue. What's causing it could be a number of things, like improper voltage going to it, maybe no voltage going to it, or a piece of debris or something stuck in the valve body and the ball just can't quite close. Whatever the case may be, we do need to address this. So what I would do in the short term is just stop the flow of hot water, and by closing one of the ball valves to the hot water coil, and until you can get addressed. But what I really want to talk about though now is the penalty. So because we are putting heat into the occupant's space, we are overheating it, and that in turn is driving down our discharge air temperature set point on our air handler. So because of that, we are now overcooling other spaces in the building, and now we're going to get the too cold complaints. That's where that symptom comes from. Another biggie here, and very energy intensive, is if you allow your boiler system and your mechanical cooling systems ever to operate at the same time, you're going to get this simultaneous heating and cooling condition. Very energy intensive. So your mechanical cooling system could get turned on because of the lower discharge air temperature set point. We could also just increase the load on our boiler by overcooling other spaces. And think about something else. Every time a boiler starts and stops, there's energy lost through the pre-purge and the post-purge. And some other things to consider is just the amount of more hours and time we put on our equipment. That does shorten its life. So remember those symptoms, keep an eye out for simultaneous heating and cooling conditions, and address them before things get out of control. I do want to thank you for watching. For additional videos on common energy reducing opportunities, subscribe to this YouTube channel or get a hold of us at strategicenergygroup.com.